All right. Hello, everyone. So, wow, not a lot of you decided to join today, but my assumption is that because this is the first of 2 midterm weeks, that some of you have lots of midterms. So, what we'll do is we'll do 1 hour today and then 1 hour tomorrow, so that you guys can have more time to study. I don't want to take away from your time to study, and we are a bit ahead topically, actually. So what we'll do is we will do conceptual database design today. I will introduce logical database design tomorrow, and then next week is the midterm, and then the following week we will finish up with logical design. Let me check my schedule. Sure, let's see. So we'll do logical design. So let's see, today is the 26th here. So next week is midterm. We can do logical and maybe physical. Okay, yeah. And then May 17th, let's see, 4, 8, 3. Okay, so then we'll finish up logical and physical. I give some last instructions for group presentations. Might move final review to May 17th, but then that following week, May 24th is when the group presentations will begin. So, wow, we're just not a lot of time left, guys. We're almost. It feels like we're only halfway through with midterm, but man, it feels like there's so little time left. So, yeah. So, like I said, what we're going to do today is we will talk about conceptual database design. By the way, also, let me also point out a couple other things. One, I made a comment about this in the chat for the midterm review channel. So one of the things that I said last week was about the notes sheet or the cheat sheet or however you want to refer to it. That you would need to take a picture of the sheet and then take a picture of you like holding the sheet, right? So you need to do that and upload it to the exam. Those will be 2 separate questions. One question will be upload the scan or image file of your cheat sheet. The other question will be upload the picture of you with your cheat sheet, and each one will be worth 5 points. So that's going to be 10 points. So if you weren't planning on making a notes sheet, I suggest you do that. I mean, I guess you could take a picture of yourself with a blank sheet of paper, but I would not suggest doing that. All right, so I want to see what type of notes you took to prepare for this exam. Okay, what kinds of things did you think were important? Okay, so you need to upload those 2 things. So go ahead and do that, and then that way I know kind of what you're thinking is important stuff that you needed to remember for this exam. Okay, all right. One other thing, hopefully today, probably tomorrow, but hopefully either today or tomorrow, I will get an example midterm from a previous semester up into the class materials folder, so you can have something that you can understand kind of how we would have done this in the past. Sadly, it'll be a paper exam that I'll be uploading. So it won't be exactly the same as the Microsoft form. This is it. This is the first time. This is the first time that we've done an exam using Microsoft Forms for this class. So we'll just have to go with that. All right. Okay. So enough talk about the exam. Let's see. Conceptual database design. All right. So we left off here. Here. So we went through, let me go back. So we left off talking about all the different steps for how to do database design, for how to do conceptual model, bird's eye view, logical model, then physical database design, including designing views and security and all of that stuff. Okay. So we did a bird's eye view last week. Now we're going to kind of drill down into the conceptual database design and talk a little bit about that today, okay? So the first thing we're wanting to do is we want to identify what are the entity types that we are going to be keeping track of. Now, one thing I said earlier, entities oftentimes in our research and in our other fact-finding techniques, things that are nouns are going to be either entities or attributes. Right? Now, the entities will be the large things that kind of have lots of properties to them. So entities will be things like people that are using that are in some way connected to our system. So it could be staff, it could be students, it could be employees, it could be lots of types of people. All right. It could also be physical things, like we might keep track of buildings because we want to know what rooms things are in. So if we were talking about like a university system, we might keep track of buildings and rooms in that building, right? But anything that has like sub attributes to it that we also need to keep track of, not a single solitary value, right? That's going to be an entity. So if you think about it, if you go back to your object-oriented days, anything that was considered a container for other attributes. So a person has lots of attributes: a name, an age, a birth date, a blood type, all kinds of, a health history, I don't know, a position at the company. Those are all things that a person has, right? So if there are attributes that go to something, then that would be most likely an entity, or it could be more than one. So take, for example, the building. We might say, well, the building has rooms, and you're absolutely correct. A building absolutely has rooms to it. But does that mean that the room is the attribute? Because the room has a room number, but is that the only thing that a room has? Well, we might want to track, we might want to know, how many seats does a room have? How many computers does a room have if it's a computer lab or if it's a classroom? What other types of things might a room have? A room might have a blackboard or a whiteboard, right? And maybe even different types of whiteboards. Maybe some rooms have what's called a smart board, right? And so these are all kinds of things that could exist in the room. So it makes more sense that a room might become an entity as well with its own attributes. All right. Okay, so once we identify all the different entity types, again, this is all based upon the different fact-finding techniques, right? Once we identify what entity types we're going to be tracking, and we say, okay, these are our entities that will eventually kind of be like our tables, some of them. Then we need to identify the relationship types. A building has rooms, right? So you might say that a building can have many rooms, but a room can only be in one building, right? Like you can't have one room be in two separate buildings. That doesn't make sense, right? So that might be a relationship that we're identifying. Another type of relationship we've talked about before is the generalization. So you might say that a room could be an office. A room could be a classroom. A room could be a bathroom, right? There's all type of room. Could be a copy room, like where the photocopies are made. So there's all different possible rooms that a room could be. And then those would be the generalization. So then we would take those and we say specialization or generalization type relationship. So we need to identify all of our has a and is a relationships. And this would include also for the has a relationships types, the aggregation composition type relationships. This would include the cardinality and participation constraints. So like I said, we said a building can have many rooms. Well, is a building required to have rooms? No, I mean, it could be a warehouse with no rooms at all, maybe. Or maybe with only one room. Yeah, I don't know. If you require your building to have rooms, what does that mean? If you don't require your building to have rooms, what does that mean? How many rooms can a building have? Well, in the real world, there is a limit, right? I mean, even buildings with the most possible rooms at all, like there's a limit. I don't know what it is. I'm sure, I don't know what the biggest building, most number of rooms in a building is in the world. I'm sure Siri or Google or Alexa or whoever could probably tell us that. All right, but we don't, but there is a real world limit. But as far as our database is concerned, do we need to specify that limit? No. I say note, rather not no. Note that if you do specify a limit, it means that you're going to have to put a constraint. If you don't specify a limit, it means that you don't have to have that constraint. Okay, so think about what that might mean for the future. But one thing I do want to say too is that we're not talking, because we're in the conceptual phase now, we're not talking about about DBMS restrictions. So we don't care right now whether our DBMS has the ability to have that constraint or not. Okay. But as for the other side of that relationship, a room can have how many buildings? Well, if a room exists, it's got to be in a building, right? So it's got to be in a building, and it can only be in one building. I mean, I don't think there are any rooms that go across two buildings. Although I could be wrong, but I don't think that there is, right? So that would be making sure we understand and analyze the relationship type between two entities. Okay. All right. So that's going to be these two things right here we're going to spend a lot of time doing that for a large system. Okay. Now, that doesn't mean that the rest of this is going to be quick, but there is going to be a lot of time doing that. And this next part is also going to be a time consumer. So we're going to identify attributes that goes with an entity or a relationship, and attributes can go with a relationship. So let's say, for example, you have a relationship between student and course, where a student takes a course, right? That's a many-to-many relationship. Well, there may be attributes associated with that relationship. Might be, what was their grade? What semester did they take that course? That kind of thing. Okay. But most of your attributes are going to be with an entity. It's going to be a person. They have the name. They have birth date. It's going to be a building. It has an address. It's going to be what else? It's going to be a phone, and the phone has a phone number and has an IMEI number and stuff like that. Okay. So these are the things, the attributes that will go with an entity or a relationship. We may need to determine attribute domains, right? Well, actually, we will need to determine the attribute domains, because for each attribute, we have to determine things like, what type is it? Is it numeric? Is it text? Is it date? Is it something else? Right? So we need to determine what type of data it is, right? And are there any constraints that we want to put on it? So for example, if we have birth date as an attribute, we might want to put a restriction that it must be in the past. We cannot have a birth date for someone born in the future. A phone number, we might want to have the phone number be have a certain format, right? And so these are some of those things. Once we have all of our attributes and our entities and all that defined, we want to determine any candidate in primary and alternate keys. So we want to get a primary key for our table. The most important one of these is the primary key, right? But we determine what the primary key is based on what our candidate keys are. So is there a candidate key? Yes, we need to determine, if there's only one, then it becomes easy. The primary key choice becomes trivial. If there's more than one candidate key, we need to choose one that makes the most sense. Okay, and we don't want to ignore the possibility that there may not be a really, really good primary key just based on the data alone. And so we might create our own primary key. All right. And again, I've used this example countless times with you guys. Your student number, your TJ Kimlik number, these both are examples of how a system might create a primary key because no natural primary key exists for the data it represents. Okay. Speaking of TJ Kimlik numbers, I'm going to celebrate today. So my family, my wife and children, they got their ecomet, they got their residence cards here. So they get to stay. They get to stay here with me. Isn't that great? Yay! In fact, you know what? I'm going to make this guy come out. Because I'm celebrating today. So we're gonna have this guy. I love this guy. So we're celebrating today. All right. All right. So primary key. There you go. All right. Enhanced modeling concepts could be specialization, generalization. Now, I consider these to be part of the relationship step, personally. Some people don't. Some people say we're just going to do all the, what's it called? We're going to do the other steps first and have all the main entities. And then if there are some specialized entities we need to create, we'll do that. Personally, this is not right or wrong. This is just how I do it. I put that up in here because I consider, and maybe it's because I'm an old UML. I love UML, but I consider the specialization and generalization to be a form of relationship. So yeah, okay. But you can put it off till here if you wish. Right? There's nothing wrong with that. One thing we will talk about today is the redundancy. Make sure there's no redundancy in the model, that there's no what's called redundant relationships. Okay, we'll talk a bit about that. We talked before, so we talked last time in previous weeks about the traps that can exist in an ER model. Redundancy is kind of the opposite of a trap. It's where we tried to, in a sense, we tried to make sure there were no traps, and instead we ended up with redundancy. So we ended up with an extra relationship that we didn't need. Okay. All right. So we're going to validate against user transactions. So we're going to make sure that our model conforms to what we need it to do. And then finally, the last step, and we're going to keep doing this is throughout the process, is we're going to review what we've come up with the user, customer, whatever word, excuse me, whatever word you want to use. Okay. And we're going to make sure that they understand what we're building and not only understand it, but that it conforms to what their requirements are. So if the user isn't sure, we need to, kind of confirm with them. We might have to go back and repeat some steps based on their input, but we need to get their input. We want to make sure we get their buy-in on this because they're the ones that are going to be using it. Okay. All right. So we might say, okay, what we're going to do is we're going to get, based on our research and based on our other fact-finding techniques, our documentation and whatnot, we go in and we find that these are some entities that we need to keep track of. All right. We might have an entity name that we are going to name it. Aliases are other words that show up. Other words that show up in the documentation or in the other research that means the same thing. Okay, so a staff is what we might call our entity, but sometimes I've noticed that in emails and in other forms of documentation and in interviews with the customer's employees, excuse me, I've noticed that they use the word employee a lot too, right? So basically what this is going to be useful for a few things. One is so that we get a good, robust understanding of what the attributes are for this entity. But two is because likely what will happen is if the system is big enough, we will be in charge of one part of it and another team will be in charge of another part. And what we will need to do is we'll need to merge those two together. And when they merge, we may need to be on the lookout for the other team using an alias, using a name for an entity that we didn't use. Okay, so if the other team called their entity employee, we need to be aware of that so that we know that those are not two separate entities, but they could be the same entity and we need to merge them into one. Okay, so property for rent, same thing. All right. Okay, and some ideas of the occurrence is kind of the idea of how this entity is seen in the system, like what's its purpose in the system. Okay. All right. And so after we get an idea of what all of our entities are and how they are related to other entities, like staff works a particular branch, what we'll do is we'll create an ER diagram. Now notice that, excuse me, notice that none of these entities have attributes yet, right? All we've done so far is we have identified the entities, identified the relation. Okay. Now, I want you to note a few things on this. One, we have a property that might be a private property and it might be a business property. And the way that we've done this is we've said, this, right? This property can be owned by 0 or 1 business owners. This property can be owned by 0 or 1 private owners. For both of them, the participation is required by the owner side. And the reason why owner is required is because if there is no owner, if a private owner or a business owner does not own a property for rent in our system, then why are we keeping track of them? Right? Okay. The reason why I point this one out is we're going to see that this relationship is actually going to change in the final version of this ER diagram. The reason it's going to change is because how do we maintain that a property for rent, right, that a property for rent could be owned by only 1 private owner or only 1 business owner? In the current setup that we have, one of the things I want to point out is the way that we would do this is we would have a foreign key in the property for rent table that points to its business owner or a foreign key that points to its private owner. Okay. So you have a foreign key column for the business owner. You have a foreign key column for the private owner column. If there is a business owner field filled, then we say that's the business owner for this property. It is a business property. If the private owner column is filled, then we say, oh, that's the private owner for this property. It's a private property. According to this, the way that this is set up, is there anything that prevents both columns being filled for a row? Was there any way, could we have a property for rent that has both the business owner field having a value and the private owner field having a value? Is there any, would this allow that? Would the current design allow that? Hmm? Okay, so currently, just based on what we see of this diagram, we could have, it is possible that a row could exist that has both a business owner and private owner, but that would make no sense. That a property could be owned by two separate people in our system. It could also be that because we allow 0 on both of these, that you could have a property that has no owner at all. And that also doesn't make any sense. So we would need to put, the way this is currently designed, we would need to put some type of check that would say one of these fields needs to be filled with a value, but both of them cannot be filled with a value. Okay. And as we'll see, that's going to be, that would be quite difficult. But anyway, so, all right. So we'll see how we'll modify that in just a little bit. But some other things I want to point out. Here we have this supervisor relationship, and we've already seen how that might not be the best way to do this. All right. We have a manages property, but we have a maximum number of properties that a person can manage. All right. And we can say a property for rent is associated with a lease. This is when a client, so notice that the client has a many-to-many relationship with property for rent where they view properties. They also have this other kind of relationship with this lease. This is when they actually rent properties. So a client can hold many leases. A property for rent can be rented many times. And one of the things we'll see when we get to the logical phase is that actually both of these are the same type of relationship. We need both of them because we want to see that a client has viewed a property, but we also want to make a distinction for when they actually lease the property from when they actually rent the place. Okay. All right. Where are we? Okay. So once we have kind of this first cut, we have all the entities and their relationships defined, then we need to start talking about our attributes. And actually, this is, I think we should have put this one earlier. This slide should have been one earlier because it shows kind of how the multiplicity does with all the relationships. All right. But here, what we need to start talking about is our attributes. All right. So we're saying, okay, a staff has some attributes, you know, name, position, gender, date of birth. We're also going to tell what kind of data it is. So it's a string, right? Or it's a character, or it's a date. Right? Can they be nulls? Yes or no? Is it a multi-valued attribute like telephone? Remember the example we gave was telephone number, where you had multiple telephone options. Okay. So then we add our primary keys in. We choose our primary keys from those entities. All right, and we say add in just the primary key. Now you can have a version of an ER diagram that has all the attributes. There's no problem with that, but sometimes it's easy just to add just the primary key. Okay. All right. So then we might say, well, you know what might help some of my requirements and some other stuff to kind of clean this up? Because like this property for rent thing with the owners, that was weird and funky. What might help this is if we did some generalization and specialization stuff. Right. So now, instead of having two separate owner entities with two separate relationships to the property for rent table, let's do this. Let's have a single relationship to an owner table and simply say that an owner has to be one of these two, either a private owner or a business owner. Oh, look at what we've been able to do now. Property for rent has one and only one owner. An owner has one to many properties for rent. Now, there is not a possibility that a property for rent could have both a private owner and a business owner. It's not possible based on this current setup now. It's also not possible that they don't have either. There must be one and only one owner. Okay. So we're making it clear we cannot have more than one owner. Notice also here, this supervises recursive relationship. We've now gotten rid of it and replaced it with a supervisor entity that is a child of the staff entity, and the supervisor has a special relationship, has a specialty that he or she can be a supervisor of staff people. Okay. If a staff person exists, they must have a supervisor. If a supervisor exists, I guess they don't have to have anybody, but okay. So we've been able to use these specialization generalization type relationships to be able to clean this diagram up to make it better understood some of the restrictions that might exist. Okay. All right. So here we have an example of a redundant relationship. Okay. Where we could say, well, we need to have a rents relationship between client and property for rent. All right. The client rents properties. And then we also have this lease, right? A client holds a lease. A lease is associated with a property for rent. Okay. Okay. So because both of these represent the same thing, right? Because both of these represent the same thing, we don't need both of them. So we can remove it. Another example, and I may go over this one tomorrow. Yeah, I may go over this one tomorrow in detail, like draw it out, because I don't have the whiteboard up right now. But is at the university system. Imagine if we had a relationship between department and teacher, and then a relationship between teacher and course. And then we also have a relationship between department and course. Well, if we require that teachers belong in a department and we require that courses be taught by teachers in the same department, right? Then what do we have? We have a situation where we can find out the department that a course is in by looking at who's teaching it. We don't have to have a relationship between department and course. Okay, I'll show this one in visual form tomorrow. Okay. And you know, it's a little bit early, but I want to leave this as a take home. I don't know, you guys are already home, many of you, but a take home thought assignment. Okay, so this isn't like a real like points assignment or anything like that. But you might think, well, here's a redundant relationship. Man married to woman. Man is the father of the child. Woman is the mother of the child. All right. And you might think, well, we don't need all those. There's redundant relationships there because we don't need all those, right? But I want you to consider, think and think about it, and we'll come back tomorrow. When we come back tomorrow, we'll open up with this discussion. Why is this not a redundant relationship? What are some possibilities where this would not be a redundant relationship? Okay, what are some possibilities, possible situations where we would need all three of these? Okay. All right. Well, let's leave there for today. I know it's a bit early, like I said, but a lot of you, there's only a few of you here anyway. So, all right, study well for your exams and do well in your exams. And I'll see you guys, some of you, tomorrow morning. All right. Have a good afternoon.